Namaste students, welcome to my channel Sumanth Tutorial. In this session, I am going to explain you the concept of the spherical mirrors. Before that, if you have not subscribed my channel, please subscribe it and don't forget to like, comment and share. Thank you. Yes students, so let us begin the concept of spherical mirrors. Before that, let me explain what a mirror is, how we can represent mirror with a diagram. See here, a straight line marked like this. This represents a mirror where this part is silver surface and another part is a reflecting surface. Clear? So the mirror can be represented like this, a straight line. If I mark like this, a small dots, so that represents the silver surface. The next to that one, the surface is called as the reflecting surface. So it's just a plain mirror. It's a plain mirror. If I say a spherical mirror, it should be in a shape of a sphere. So let me draw it. First, let me draw a sphere. Let me break down it like this. One, I will silver inside. Another one, silver outside. This is silver surface. And this is reflecting. Likewise, outside here it is silver, inside is reflecting. So let me say one more time. A spherical mirror, it will be curved in shape. That is consist of two surfaces. One is a reflecting surface, another one is the silver surface. The ray of light reflects on the reflecting surface. Here, if you observe one spherical mirror having the reflecting surface outside, whereas the silver surface inside. In another one, the silver surface is outside and reflecting surface inside. Clear? Based on these things, we divide broadly the spherical mirror into two types. One is concave mirror, another one is convex mirror. Yes students, in a mirror, if the reflecting surface is outside and the silver surface is inside, we call it as convex mirror. Or in another way, if a spherical mirror having the silver surface outside and the reflecting surface inside, we call it as concave mirror. Clear up? So convex mirror means reflecting surface outside. In a concave mirror, reflecting surface inside. So these two are the types of a spherical mirror. Now let us study few terms related to this spherical mirror. Pole. A pole is the geometric center of a spherical mirror. So it will be exactly at the center of the aperture. For example, let me take a spherical mirror, silver outside. So it is very clear that it's a concave mirror. That may be the concave or that may be the convex mirror. Pole remains the same. See here, this reflecting surface is the aperture. If I mark here A, B, and midpoint as B. So this is the pole of the spherical mirror. So that may be for the concave mirror or that may be for the convex mirror. Pole definition remains same. So it is the geometric center of the spherical mirror, or we can also say it as it is exactly the midpoint of the reflecting surface or the aperture. One more, center of curvature. See here, center of curvature is the center of the sphere where mirror is a part. Means, see here, if I draw a concave mirror, if I extend this line, this becomes a sphere and C as the center. So, a center of curvature of a sphere is the center of the sphere where mirror is just a part. Only the part is the mirror, and the center of the sphere represents the center of curvature represented by C. Now, radius of curvature of a sphere. The general definition of a radius says that a radius is a line joining the center to the circumference of a circle. See here now, the radius of curvature of the mirror says that it is the radius of this sphere where the mirror is a part. I repeat, the radius of curvature of a spherical mirror is the radius of this sphere where the mirror is a part. So if I mark here R, this distance represent the radius of curvature of a spherical mirror. Now the principal axis. The principal axis is the line joining the pole and the center of curvature. So let me draw a concave mirror, the pole and center of curvature. If a straight line joins the center of curvature and the pole, that is called as the principal axis of a spherical mirror. Now let us study the concept of focus and focal length. See here, in a concave mirror, if the ray of light passing in this direction, after touching the reflecting surface, it bounces back and focus to one point. Let me draw one more line like this. After reflecting, it bounces back and reaches one point. That point is called as the focus. So how we are going to define the focus? In a mirror, when the ray of light after reflecting, it meets to one point, that point is called as the focus, and the distance between the focus to the pole is called as the focal length. I repeat, the distance between the focus from the pole is called as the focal length. Yes, students. Now observe, the focal length is half of the radius of curvature. So this is the standard one that you should remember always. This focal length will be always half of the radius of the curvature. For example, if the focal length is 30 centimeter, or we can say right. So if the radius of curvature is 50 meter, then focal length will be 100 meter. That's all. So in other words, focal length is half of the radius of curvature, or radius of curvature is twice the focal length. Yes students, after learning with the concept of these terms related to the spherical mirror, one question arises, will this spherical mirror obeys the laws of reflection? Yes, 100%. This spherical mirror also obeys the laws of reflection. So what are the laws of reflection? First one, the angle of incidence is always equal to the angle of reflection. Second one, the incident ray, reflected ray and the point of incidence all lies in a same plane. So 100% this spherical mirror will also obey all the laws of reflection. Yes students, if the laws of reflection, it is very clear. Now I am going to discuss with you the rules for making the ray diagram. So if you are writing the ray diagram with the help of a convex or the concave mirror, or I can say very clearly a spherical mirror, few rules that we need to follow. There are 3 rules that we need to follow while making the ray diagram. The first one, the object is always placed in front of a spherical mirror, that to its left side. I repeat, we are going to keep the object to the left side of a spherical mirror. For example, if I draw a spherical mirror like this, the object will be placed here. That is the first rule. Second rule, when you are going to place the object, the foot of the object must touch the principal axis. Means it is very clear that we are going to keep the object on the principal axis. And the third one, if we want to draw the ray diagram, we need to take 2 convenient rays so that after reflection, so we can use it. So these are the 3 laws that we need to follow. I repeat, which are those? First one, the object must be placed in front of a mirror to the left side. Second one, the object must be placed on the principal axis. Third one, we are going to take 2 convenient rays to draw the formation of images. Yes students, now I am going to say a very important convenient rays which will be applicable while we are going to use the ray diagram, and it is always benefit if you learn that one. It is a very easy and most important. So there are 3 conditions which is present when we are going to use any of the spherical mirror. That may be the concave or that may be the convex. So let me draw a concave mirror having the principal axis, center of curvature and a focus. First law, so there is no first, second or third, it's just for the numerical value I had said. So the first one, if the ray of light is parallel to the principal axis, after reflection it will pass through the focus. Very important. I repeat, if the ray of light parallel to the principal axis, after reflection it passes through the focus, that may be on either side. Clear? Second one, now the second one, the ray of light which is already passing through the focus, if it is passing through the focus, after reflection it will be moving parallel. That may be on either side. Imagine the ray of light like this, which is already passing through the focus. After reflection, it will be parallel to the principal axis. Now, if the ray of light passing through the center of curvature, it will pass as it is without deviation. I repeat, if the ray of light is passing through the center of curvature, so it will bounce back in the same direction without changing its path. And also we can add one more. If it is reflecting at the pole, it will be oblique. This is also we used to use. But normally we are going to use first three steps. That is, if the ray of light is parallel, after reflecting it passes through the focus. Or if it is already passing through the focus, after reflection it will be parallel. Or if it is moving through the center of curvature, it will pass without deviation, means it will reflect back in the same direction. And finally, when it is reaching at the pole, it will be oblique, making the same angle. So I and R, I is equal to R. That's all. Angle of incidence is equal to angle of reflection. Yes, students. Now, with one example, I am going to show you how we can draw a ray diagram with the help of a concave mirror. Imagine, I have written here a concave mirror, principal axis, pole, focus, center of curvature. Imagine that I just kept an object here. Just as a basic example, just remember the class which I have done based on the lens. The same procedure we are going to follow here also. First, a ray of light which is parallel to the principal axis. After reflecting, it passes through the focus. Clear? This is one rule. Another one, a ray of light passing through the center of curvature will not deviate. Then where the image is going to form? Here. So this is the rule we are going to follow to construct the ray diagram. Very easy and simple. Imagine that we have kept an object beyond center of curvature. How we can draw the ray diagram? Very simple. We need to take two rays. One is parallel. After reflecting, it will pass through the focus. Another one, the ray of light which is passing through the center of curvature. So the image is going to form will be real and inverted. It's a real, inverted, and if you want to speak with the size, it will be small. Or I can say it is diminished. So like this, you can take different examples by placing it with a different position, and also you can make a table just like a lens. So how the image is going to form. So that will be very nice and very easy. But remember the basic rule. So the line must be straight and parallel. One must be parallel after reflecting. It should pass through the focus. Another from the tip, which is passing undeviated through the center of curvature. So you will get one intersecting point So that point will going to give you the place where image is going to form. That's all. Yes, students, thank you for your support. So once again, I'm requesting you, if you have not subscribed, please subscribe my channel. Along with that one, don't forget to like, comment and share. Thank you.